Okay, we're going to jump right in and do another optimization problem, and this one involves it's sort of a business application. It involves maximizing revenue for a particular situation, and we're going to consider changing the price per person, the ticket price, or it's called a fare price when you ride a train here. We're going to consider making changes to this in order to increase revenue, possibly increase revenue, and see how it affects revenue. Okay, so here's the situation. A commuter train carries 2,000 passengers every day, daily, from a suburb into a large city. The cost to ride the train is $7 per person. Now, market research, the company's done some market research, and it shows that if they change the price, the $7 per person, if they change it by 10-cent increases, okay, so if they raise it to $7.10 or $7.20, for every fare increase, it's going to result in 40 people, okay, it's going to result in 40 fewer people taking the train. They decide that, hey, the price is rising too much. I'm going to walk or find another way to go here. And the reverse happens. If they decrease it by 10 cents, more people might want to take it. And that's 40 more people would consider riding the train if they decrease the fare by 10 cents. Now, the capacity of the train has a certain effect on this. Okay, the train company can't operate their train if they don't have at least 1,600 passengers. Okay, so the 1,600, okay, is going to be our lower boundary here. Okay, and we'll deal with this in a second. Okay, that 1,600 is used to pay for regular expenses. I mean, sort of those set or those constant costs, right? I mean, the train has to operate. There has to be a driver. There's insurance. There's general maintenance, and they can't go lower than 1,600 passengers. Now, also playing into this domain is the 2,600. Okay, the 2,600 is the number of maximum passengers for safety reasons, maybe seats, whatever the case may be. So the passengers, okay, lie between 2,600 and 1,600. Okay, now we're trying to decide, okay, how much I should increase the fare, okay, increase it or decrease it, okay, in order to maximize revenue. So I'm going to start this one a little differently. Okay, I'm going to let X be the number of fare, okay, or that's ticket price changes. I'm going to use the word changes. Now, a change means increase or decrease. I don't know exactly which one's going to happen. Is it going to be an increase or is it going to be a decrease? Okay, but we'll see. Okay. Now, the passengers, in terms of X, okay, we have that information. And the number of passengers that take that is 2,000. Okay. And I'm going to go minus 40X. Okay. So I'm going to assume, and as I start my mathematics of this type of question, I'm going to assume that the X is going to be a positive number, okay? So if I increase this expression right here, so let's say if I make 2 increases, right? If I decide to make 2 increases, so X would equal 2, it's going to result in 80 less people. So the 2 would go in here, right? Take away 40 times 2, okay, so that's a negative 80. So from 2,000, I'd lose 80 passengers here. Okay, does that make some sense? Now, if I decide to, okay, if X is negative, so I decide to decrease it, okay, if I put a negative here, I'm adding 40 more. Negative times a negative, right? I'd be adding 40 more. Now I can do the same type of expression with ticket price. Okay, my ticket price, okay, is going to be similar type of expression. My ticket price per person is $7. Okay, and I'm considering, okay, increasing my price by increments of 40, but okay, the X would be positive or negative, and that results in an increase of 10 cents, right? An increase of 10 cents, okay, onto that $7. Okay, good. Now, before I start the revenue function, I'm going to think about my domain restriction. Now, remember what I did up here, passengers. My passengers have to fall, okay, in between this interval, right? This was the passengers situation up here. And the expression for my passengers is 2,000 minus 40x. Okay, so if I can try and solve this inequality, okay, basically look at this situation here where 1600 equals 2000 minus 40x. If I solve this inequality for x, okay, I'm not sure what your experience is with solving an inequality like this, okay, but I isolate the one situation. So over here, just this one, 1600 equals 2000 minus 40x is going to give me, okay, a situation where I'm dividing by, let's do this a little bit differently here. Okay, let's just go down here and go like this. This is the one situation I'm going to try and solve here. Let's do this properly. Okay, so let's bring over the 2000. So if I bring over the 2000, I'm going to have 1600 minus 2000 plus a negative 40x. Okay, that's negative 400 less than 40x. And when I solve an inequality and I divide by a negative, I have to flip the inequality, and that's 10. Okay, so x has to be less than 10. Okay, x has to be less than 10. So I'm going to write that, okay, over in here. Okay, and I'm going to solve the second piece of this as well too. Okay, and where I have to go to 2600, so I've got, okay, 2000 minus 40x, and that's less than 2600. Okay. Division by 0 flips my inequality here. Okay. So when I divide by 0, don't know if you remember that, if you've ever done some work with inequalities. Okay, and that means x has got to be greater than negative 15. Okay, so I can only drop my price by 15 increments, or I can only raise it by 10 increments, and the negative 15 goes here. Okay, so this is my domain restriction, and all my answers are going to try and lie between negative 15 and 10. Okay, so I can drop it 15 times, or I can raise it 10 times. And that, okay, those limits in terms of x, okay, relate to, or directly relate to, the passengers falling between 1600 and 2600. All right, so let's just separate this and get some space here. Okay, now we have our passengers expression, we have our ticket price expression. The revenue that this company makes is the number of passengers times the ticket price. Okay, it's that easy. It's the only way the company makes money here. Okay, by taking a certain number of passengers and multiplying it by each number of tickets. So as a revenue function, that's going to be the product of these two binomials. Okay, I'm just going to do FOIL on that and work it all out. I've got 14, if I did my math correctly, according to my notes here beside me. Okay, I've got minus 80x, and then a minus 4x squared. All right, we know what to do next. I hope we do. Okay, that results in negative 80 minus 8x, and hopefully we still know what to do. I want to set my derivative function equal to 0, because I'm looking for the maximum, right? I want to maximize or optimize this relationship here. Find the optimal revenue. And it looks like I have negative 10. So I have negative 10, okay? And that represents decreases of 10, okay? So, does that fit in my boundary? Okay, absolutely it does. Negative 10 is in this area here. Okay, so good. So I'm just going to do an endpoint check. I want to check my revenue at negative 15, my first endpoint. I want to check my revenue at -10, and I want to check my revenue at +10, and just confirm, okay, what these are. Now I'm going to use my revenue function right here. That's fine. That's easy to do. Okay, so I've got at -15, I've got, okay, I've got how many passengers at -15? I've got -15 in here. I've got 2,600 passengers. Okay, and I've got at -15, I've got, okay, got $1.50. Okay, off of my ticket price is $7, right? All I'm putting in is -15 in here and here. Okay, so that's $5.50 per ticket, right? There's been 15 drops. That amounts to 600 more passengers and $1.50 off my ticket price. And that gives me, I think if I did this correctly, okay, that gives me a revenue of $14,300 every day. Okay, at -10, I think was our optimal amount. At -10, I'm going to put -10 in here. That adds 400 to this. And if I put -10 in here, that takes that ticket price down to $6. So I'm going to have 2,400 passengers, and my ticket price is going to be $6. And that's a revenue of 14,400. Okay, the next is 10. If I decided to increase my ticket price by 10 increments, that would be a new ticket price of $8. So 10 in here, add $1 to it, that's $8, and a 10 in here, that would take 400 off. So I'd have, no, not 400 off. Well, yeah, I'd have 400 off. So from 2,000, I take 400 off. I've got 1,600 passengers at a price of $8. Okay? And that amounts to a revenue of $1,280. Okay, so clearly this is our maximum revenue, and my sentence should be, okay, so what fare should the railroad charge? Okay, the railway should charge a fare of, what did we say, $6? I'm just going to be pretty more specific. Per ticket, this would result in how many people riding? 2,400 passengers per day, and revenue of might as well be specific. I calculated all of that, so I found it, and I wasn't asked that, but that's fine. It's easy to write a sentence and do that. Okay, great. That's how we do a revenue one. The next video will be another cost one, but it's quite a complicated situation, and we'll get that set up next. Thank you.